Good morning, students.
Good morning, ma'am.
Good morning. We are learning this last topic of Unit 5. We covered performance. What is performance and how performance is measured? What is the significance of performance? An example. And what is execution time? What are the parts of execution time? And how can we express performance with respect to time? And how can time be measured um, as performance and clock cycles? The next topic is CPU time and its factors. What is CPU time? CPU time is equal to clock cycles for a program by clock cycles time. Clock cycle time means, you see, we learned when we studied RISC, CISC that a CPU would execute instructions in clock cycles, and then clock cycles would be expressed as you know kilohertz, megahertz, gigahertz. That is CPU time. CPU time we can measure. We can say that 2.5 gigahertz is the CPU clock cycle, which means CPU can execute 2.5 billion instructions per second. Now, essentially, we are looking at the CPU time with respect to a program. So, clock cycles for a program, for a particular program, how many clock cycles are required? In order to determine the CPU time, this all into clock cycle time. Clock cycle, what is the clock cycle time and how many clock cycles required for the program, which is equal to clock cycles for a program over clock rate. Clock rate means the rate of the CPU. Instruction count into cycles per instruction by clock rate, which evaluates to this instruction count if suppose there are 10 instructions. Cycles per instruction, if we can execute consider, let us take a small example, hypothetically, 100 cycles per instruction, or for instruction, we don't need 100 cycles, we need only 3 or 4 cycles. Instruction, there are 10 instructions and 3 cycles per instruction. And what is the clock rate? Consider CPU can execute 100 instructions per second. In reality, it is much more. For a simplified example, here I am considering 100. That gives rise to instruction count into um, clock cycles per cycles per instruction over clock rate. This cycles per instruction can be written in the form of CPI, which is equal to this is sum I CPI sub I into C sub I. This sum means what? This summation is for 10 instructions. Let us take this total number of instructions. You can put as this sigma I equal to 1 to n, where n here in this case would be 10. CPI is 10, no, not 10, 3. Cycles per instruction 3. It may vary. Some instructions might require 4 cycles. So it is cycle per instruction of sub I. Sub I means for that particular instruction within a program. CI is clock rate of I. CI is the count, the number of instructions of class I executed. Okay, here this CI denotes the count of the number of instructions of class I executed. If there are out of these 10 instructions, if there are 5 instructions that require 3 cycles, if there are another 5 that requires 4, this require 3 cycles, this require 4 cycles. This would count. CPU clock cycles would be equal to this summation of cycles per instruction. For 5 it would be 3, for remaining 5 it would be 4, into CI. CI is the count of the number of instructions of class I executed. Here CI would be 5 for one particular class. If you take 2 classes, 5 one class, 5 another class. Here the whole idea is you should understand that to find the CPU clock cycles, we have to do it for program. In a program, there are several instructions. To count the instructions, this sigma or summation is used. This you are counting for example, first instruction, 3 cycles of belonging to class 1. If you divide these into 2 classes, class 1 and class 2, this would be 3. Second one would be 3 into 1, again 3. Third one would be 4 into 2. This would be 8. Like that you get for 10 instructions. We are assuming that there are 10 instructions. And if it comes out to 15 plus 40, 55. So total number of CPU clock cycles required to execute that particular program would be 55. This is how that calculation would be carried out. CPI. CPI is cycles per instruction. The average number of clock cycles each instruction takes to execute. CPI is the average number of clock cycles each instruction takes to execute. and the one way to compare two different implementations for the same instruction set. This is the method that can be leveraged in order to compare two different implementations of the same instruction set. We have same instruction set, but different implementations. To compare, this CPI would be used. Overall CPI for a program is equal to number of cycles for each instruction type, the frequency of each instruction type in the program execution. Number of cycles for each instruction type means there would be different instruction types. We may have a memory instruction, register reference instruction, IO instruction. So for these different instructions, how many cycles are used, number of cycles for each instruction type, and also frequency for each instruction type in the program execution. How many times memory reference instructions are occurring? Frequency means the count, how many times it is occurring. And this one denotes the overall if you look at here, we are trying to determine the CPU time. In order to determine the CPU time, clock cycles per instruction was used. Here, if you look at here, CPI sub I, this cycle per instruction, it is denoting number of cycles required for one particular instruction. That one we looked at in detail here. Here it says that a way to compare two different implementation would be this CPI, and its CPI comprises of number of cycles for each instruction type and frequency of each instruction. And moving on to this performance equation would be used in order to determine the CPU time. CPU time, which is equal to seconds by program. How many seconds are taken for a program, which can be expanded into this form. Instructions per program into cycles per instruction into seconds per cycle. Instructions per program. You write one program. Let us take example of arithmetic operation program which you have written in C language. How many instructions are there in that program? Let us consider 10 instructions are there. So per program 10 instructions into, this would be 10 by 1 into cycles per instruction. Per instruction, how many cycles are required? CPU cycles. Let us say one cycle. One cycle for one instruction into seconds per cycle. How many seconds are required for each cycle? Let us say 2 seconds are required. This is just an example. It's not 2 seconds. Within second, billions of instructions are executed and cycles would be processed. For simplicity's sake, this would be written in this form. So performance is determined by execution time. performance of a computer or of a program means how much time it is taking for execution. Do any of the other variables equal performance? The question here is, uh, besides execution time, what are the other variables that will that is equal to the performance? Well, the variables given are here: number of cycles to execute a program, how many cycles are required to execute a program, number of instructions in a program, number of cycles per second, average number of cycles per instruction, average number of instructions per second. These are all the variables that would have impact on the performance. Uh, MIPS is like a metric, million instructions per second. If it is said that a computer has got 10 MIPS, it implies to saying that it can execute 10 million instructions per second. Another question is when it is fair to compare two processors using MIPS. Consider there is a processor i3, there is a processor i5, there is a processor i7. When it is fair enough to compare these processors, different processors using MIPS, million instructions per second. Well, the answer to this would be when everything, all the factors are similar, when all the factors of a processor and of a system is same, then we can go for million instructions per second. How can the factors be determined? What are the factors? The factors like instruction count, cycles per instruction, clock cycles. How you will know which processor has uh, how many cycles per instruction, what is its clock cycle? In order to determine that, the software first, how many instructions are there that can be uh, known by using a profile, a tool known as profiling. Profiling is a software tool. No, actually, profiling is the process. There would be software tools like when you use Turbo CPP, you might have a option there, which says profiling the program. This profiling would give the approximate instruction count or actual instruction count. This instruction count could also be determined from simulator of the architecture. A simulator means the one that is not actual machine, but that behaves like an actual machine through modeling. That is a simulator. When you go and buy a vehicle, there you might have seen the vehicle simulator. There will be vehicle placed, and here you will see there is a screen. When you sit on this vehicle and you uh, start riding, that riding would be simulated here on this screen. You feel that you are actually riding, but you are not riding. You are stationary. You are sitting at one place, and that process of riding has been simulated. That way, our simulators of computer systems would be there, that would give the architecture details and the instruction count. Hardware counters, when you have hardware counters uh, that count the instructions when it is actually being executed in the hardware, the accuracy would vary because different hardware would count differently. If it is identical hardware, then can be giving the same accuracy. You can measure it without knowing the CPU implementation. How can this instruction count be measured without knowing the CPU implementation? This can be done uh, through, uh, uh, you know, by again through modeling. Uh, if there is one instruction, if there is a program that has got a few instructions, those instructions could be measured. Actually, in hardware, how many uh, they would get translated into. This one instruction perhaps would be mapped to three instructions in hardware in machine language. That could be done without actually writing the program in computer system. By using tools, also this kind of measurement would be done. CPI cycles per instruction, depending on design details of the computer, cy- uh, cycles per instruction would be uh, known. Depends on design details. Some computers are very advanced, some are too basic, and some are like moderate. Cycles per instruction uh, is dependent on the details of the computer. Without the computer details, directly it cannot be found how many cycles would be taken for instruction. By detailed simulation or hardware counter. If there is a hardware counter means this program, whatever program you write in C or Java would be converted into machine language, right? This machine language program would have more number of lines. How many lines are actually there and how many lines are being executed? That could be counted by a hardware counter. Hardware counter. All right. This hardware counter, when it executes one instruction, it increases the count plus one. Another instruction plus one. When by the time it reaches the end of the program, this hardware counter would have the total count of the instructions. From that also, cycles per instruction would be calculated. And mainly from the manuals of processor, cycles per instruction would be actually known for sure. How many cycles per instruction would be described in the manual of the processor, and clock cycle would also be described in the manual of the processor. How to improve the performance? In order to improve the performance, the instruction count could be reduced. If there are 10 instructions to execute and if it takes 10 seconds, when the count of these instructions when the count of these instructions are reduced from 10 to 5, the total time to execute would be reduced from 10 seconds to 5 seconds. And another way is increase the number of instructions per cycle. Per cycle, how many instructions are executed? Actually, in one cycle, millions and billions of instructions are executed in a real-time computer. If you simplify it, if you say that one instruction for one cycle, and if this count is increased, two instructions per cycle, again the performance would be improved. Another mechanism through which performance could be improved is the concurrent execution. What is concurrent execution? This is parallel processing or pipelining. Simultaneously, several instructions are executed, which is known as concurrent execution of instructions. Through this, also performance would be improved. Increase the clock rate. If the clock rate of one processor is 2.5 gigahertz, if it is increased to 4.5 gigahertz, obviously the performance would improve. These are the ways through which performance of a system would be improved. First one is instruction count should be reduced. If there are less instructions, it takes less time to execute. A number of instruction per cycle should be increased so that you can execute more number of instructions in one cycle. And clock rate can also be increased. That clock rate would specify how many cycles we get per second. The next topic is how hardware and software affect performance. If there is a efficient algorithm, that is the software impact of the performance. That's why algorithm, whenever you design algorithm, it should be memory efficient and time efficient. If it is time efficient, it means that it is executing in less time. Instruction count, that algorithm comprises of instruction count, this cycles per instruction. These two are encompasses into what is known as an algorithm. Algorithm should have less number of instructions and more clock cycle per instruction. Means how many instructions would be from this algorithm would be executed. That is with respect to algorithm. Programming language. In now you are learning C and Java programming language. If you could write a program in 10 lines in C, you could write that in 2 lines in Python, which you will learn in your next semester. So programming language also has an impact on the performance of a program. In which programming language program has been written. If it is written in a language which is very efficient. Uh, Apparently, it takes less number of instructions, and cycles per instruction. If there is some indirect code included in the instruction, the number of cycles to execute would be more. So, the number of cycles per instruction uh, could be reduced if you have direct and short code lines. Compiler also has an influence over this performance. Even compiler, when it is translating a language from high language to low language or machine language, would would have a effect how well when 3 lines of program is converted to 30 lines, or 3 lines of program is converted to 10 lines. There is a difference of the instruction count, and this is because of the compiler. It is the compiler that would convert the high level language program into machine language, and how efficiently it does also determines the performance. Same cycles per instruction in compiler also. Another important point here is instruction set architecture. Which instruction set architecture is used? We learned that RISC, CISC instruction sets. So, which instruction set architecture computer belongs to? If it is RISC, it will be less instructions. If it is CISC, you will have more number of instructions. So, the architecture of computer belongs to which uh, instruction set format, that also influence this performance. Instruction count, again here, based on the architecture, the instruction count would be generated. For instance, if the architecture is um, having support for more instructions, you may require less number of um, instructions, because directly you like if you have three address instruction set, if there is a three address instruction set, you can perform that operation 3 A into A into B plus C into D. This would be done in just 3 lines of code. If there are three address instructions, if there are two address instructions, this would take perhaps 6 instructions. If there is only one, it would take 9, 10 instructions. So this architecture also has an effect on the performance. Same if if it is less number of instruction cycles per instruction would also reduce if you have less number of instructions. Clock rate will also be determined. Clock rate also plays a vital role in the performance. If the clock rate is high, more number of instructions would be executed. And if there are any other underlying architecture issues, which includes pipeline, pipeline is to execute in parallel. Again, for that also, this cycles per instructions and clock rate uh, have an impact, and if there is a pipeline, this would be reduced. Uh, Cycles per instruction would be reduced, but then for that, clock rate should be high. And memory system also uh, up, plays a very significant role. If it is a very fast memory, it takes less time. If it is slow memory, it takes more time. So all these are the hardware and software uh, factors that affect the performance. And what are the aspects of CPU performance? CPU performance includes this instructions per program into cycles per instruction into cycles per second. And these are the various parameters. For algorithm, instruction count and this cycles per instruction. These both means algorithm has impact on these two. Good algorithm would increase the instruction count, also increase the number of um, instructions per cycle. Here, programming language also would have effect on these instruction count and CPI cycles per instruction, compilers as well. This instruction set architecture has these two as well as the third one, which is clock rate. This clock rate is determined and would be would be impacted only with respect to instruction set. Other things, this clock rate do not have direct uh, link. The summary for the performance is determined by execution time, and the other variables that are included in the performance are number of cycles to execute program, number of instructions in program, number of cycles per second. This is average number of cycles per instructions, average number of instructions per second. These all factors also uh, impact the performance. Common pitfall: thinking one of the variable is indicative of performance when it really isn't. What is a common problem that um, designers, computer program designers or computer hardware designers would come across is that they think that one particular variable or a factor would have a direct influence on the performance. However, it would not have that much impact. It would not affect the performance. It is like a dummy variable. So it is really essential to have a thorough understanding of all the variables that are affecting the performance. Time is the reliable measurement for performance. Eventually, whatever you use to measure the performance, time is the most reliable measurement. And through time only, uh, these different programs would also be compared. Whereas other factors, if there are other factors, they may not be able to directly compare. All right, that is all about performance. Students, do you have any doubts in so far whatever we have learned?
No, ma'am.
Is everything clear?
Yes, ma'am.
Okay. So now